Today we will be looking at the VMmanager virtualization platform. The product is developed by ISP System. We have been evolving VMmanager for over 15 years. Here is the platform's main screen. On the left, you will find the menu for managing virtual infrastructure objects. On the right is the platform settings menu. The center section displays dashboards. The top dashboard shows cluster information. VMmanager supports clustering for infrastructure scalability. We understand a cluster as a group of servers located in a single location. The key features of these servers, cluster nodes, are their location and high-speed communication between them. VMmanager is built on a microservice architecture as it was initially designed for high workloads. The largest current installation consists of 350 physical nodes and 25,000 virtual machines in a single platform. Every operation in VMmanager is handled by the Task Manager. The next widget displays information about tasks launched within 24 hours. We will examine the Task Manager in more detail later. The next widget shows resource utilization data on the server where VMmanager is installed. This could be either a virtual or a physical server, license information, and platform version. VMmanager installs on an Alma Linux system. Under the hood, VMmanager includes built-in Grafana service. We use it to generate diagrams. The main screen displays real-time load on virtualization nodes. When selecting a node, you can see information about which VMs on that node are consuming the most resources. You can create custom node lists for monitoring. The primary way to view information about platform objects is through tables with summary data. Detailed information about an object, its settings and history are displayed in the object card. To access the card, click on the object name and then select parameters. The platform's tables have two display modes, full and compact. You can adjust the view through Table Settings menu. To sort or filter, click on Column Headers. Each line ends with an ellipsis. When you click on it, a menu of available operations for that object shows up. When multiple lines are selected, group operations become available at the top of the table. To quickly access frequently used interface pages, you can bookmark them. For example, you can save a filtered virtual machine table to bookmarks. Bookmark management is available in the right-hand menu. Now, let us review the main virtual infrastructure objects that VMmanager manages. Users. The platform allows you to create users. Currently, the role model includes three main roles. Administrator with full access. Advanced user can independently create virtual machines without binding them to physical resources. Users can manage virtual machines that were created for them. Each user has its own personal client area. Platform users can be grouped, and a range of IP addresses can be specified to restrict VMmanager access. User synchronization with LDAP, Active Directory, Free IPA, and LD Pro directories is supported, both on a schedule and manually. Two-factor authentication is supported. Users can modify their settings in the client area, set their first and last name, select the interface language and time zone, change their password, enable two-factor authentication, add SSH keys for authentication when accessing virtual machines via SSH protocol. Users can monitor and manage their active sessions in the client area. Templates. Immediately after installation, the platform provides access to operating system templates from the ISP System repository. At the same time, it is possible to create and connect custom or external repositories with operating system templates. In addition, users can create and connect libraries with ISO images that may be located on shared HTTP or FTP servers or on shared NAS storage, as well as create and edit virtual machine configuration templates. A configuration template is a set of resources and limitations that can be used when creating a virtual machine. Using templates eliminates the need to specify parameters each time a new virtual machine is created. The configuration template specifies the number of CPU cores, the amount of RAM, the disk size. Through a tag, it specifies on which storage the virtual machine's disk should be located. Additionally, it is possible to specify multiple disks on various storage devices, set limits for incoming and outgoing traffic speed, set priorities for CPU time usage and I/O operations, limit the number of incoming and outgoing TCP connections, enable anti-spoofing function, configure port restrictions, specify settings for user work with snapshots, allow saving RAM state, set available snapshot limits. The use of configuration templates and operating system templates allows for quick creation of virtual machines with the required specifications. However, using templates is not mandatory. Networks. VMmanager. Built-in module for IP address space management can be found in the Networks menu. The settings describe IPv4 or IPv6 physical networks that are planned for usage. Networks can be divided into IP address pools and assigned to certain clusters. IP Addresses tab includes information about the issued IP addresses. It is also possible to view the field addresses for each network. Operation history is logged. DNSBL service allows for checking an IP address against blacklists prior to issuing. Virtual Networks menu is available for user VXLAN. Clusters. Let us proceed to the list of clusters. For each cluster, the following information is available: resource utilization, number of nodes, number of virtual machines in the cluster, and connected storage systems. In the cluster card, general settings are configured, such as time zone, DNS servers, and available operating system templates. Permissions are set for working with SPICE protocol, uploading custom ISO images, and performing operations with virtual machine disks. A domain template is specified for virtual machines. Permission is granted to modify the domain name. VMmanager supports configuration of the overselling ratio. This is the oversubscription ratio for vCPU and RAM. The user can limit the number of virtual machines created on nodes. These settings will be applied to the node where it is added to the cluster. Individual settings can be configured for each node. At the cluster level, you can specify how VMmanager will distribute virtual machines during creation. With balanced distribution, each new virtual machine will be created on the least loaded node in the cluster. Using distribution filters, you can set conditions for which operating systems, configurations, and resources to place virtual machines in the cluster, or specify a complex filter using logical operators. When creating a cluster, directories are specified for storing images, backups, and operating system templates. These directories are located on the local disks of nodes. When a template is first accessed, it will be downloaded from the repository to the node and subsequently used locally. If necessary, load balancing can be enabled in the cluster. To enable the balancer, you need to specify the balance check interval. The platform analyzes the status of virtualization nodes. If any node is overloaded by CPU or RAM by more than 70%, a decision is made to migrate a virtual machine from this node to the least loaded node in the cluster. During one iteration, one virtual machine is migrated, which causes the least imbalance. Thus, by changing the balance check interval, you adjust the aggressiveness of balancing. The History tab displays information about which virtual machines and which nodes participated in balancing and exactly when. Network configuration in a cluster. VMmanager offers 3 types of network settings. They differ in the order of assigning IP addresses to virtual machines and the topology of network design. The network configuration type is set when creating a cluster and is displayed in its card. Let us examine the key differences. Switching configuration mode. Virtual switches based on Linux Bridge. This configuration allows for virtual machine migration, both within a cluster and between clusters. Routing configuration mode is also based on Linux Bridge. It is designed for equipment with port security functionality located in data centers. This feature filters traffic from a node by MAC address. Since virtual machines have their own MAC addresses, their traffic will be blocked. Routing mode bypasses this limitation. However, virtual machine migration from such cluster will be impossible. IP Fabric is our proprietary solution, which is a pure L3 network. Virtual machines are assigned an IP address with a /32 mask, allowing for efficient use of public IP addresses. An IP Fabric cluster can only be created in a network that supports internal BGP routing. Route information is propagated by route reflector hardware, which can be either physical or virtual routers. In the cluster network settings, IP address pools are specified from which addresses will be assigned to virtual machines. A test IP address is also set, which is usually the gateway address. After making changes to the cluster node settings, agents on the nodes check the availability of the specified address. If the address is unreachable, the settings will not be applied on the nodes. This ensures that node connectivity is not lost during configuration changes. To standardize network settings across all cluster nodes and enable centralized management, the distributed switch mode can be used. Cluster settings enable VXLAN support. These are private networks for connecting users' virtual machines. Two operation modes are supported. Full mesh mode, which is a star-type connection. It requires no additional configuration, but uses broadcast traffic between nodes, which imposes certain limitations on the number of nodes in such a cluster. Root reflector mode removes these limitations, allowing users' virtual machines to be connected both within and between clusters. The root reflector can be either physical hardware or a virtual machine. A script for installing and configuring such virtual machine is also available out of the box. The cluster card configures storage for virtual machine disks. You can connect local storage, file storage, or LVM storage. Storage tagging is supported, allowing you to specify a tag when creating a virtual machine and place its disk in the desired storage. Supported network storage types for clusters. Ceph storage, any SAN storage, connected via SCSI fiber channel or InfiniBand. VMmanager itself works with a block device connected to the cluster nodes, creates an LVM storage on it, and manages virtual machine disks through it. To connect, you must specify the path to the block device. A cluster can also be connected to a shared NAS storage with a clustered file system. In this case, you must specify the directory where the NAS storage is mounted. When using local file storage or shared NAS storage, virtual machine disks are a COCO2 format. With LVM or network SAN storage, disks are in RAW format. The number of storage units in a cluster is unlimited. If a cluster has 3 or more nodes and shared network storage, high availability HA mode can be enabled. To do this, an additional test IP address must be specified. If the node loses connection with the cluster, it will check the availability of this IP. If the IP is unreachable, the node will be isolated and virtual machine relocation will begin. If the IP is reachable, the node will be excluded from the HA cluster and virtual machines on it will continue running. When enabling HA mode, you must specify which virtual machines should be automatically restored in case of a node failure and set their recovery order. The Node section displays the list of nodes participating in HA and the status of the HA agent services on them. Cluster creation is performed via a wizard with 4 steps: General Settings, Access and Resources, Storage Configuration Rule, Network Configuration Rule. After creation, the cluster appears in the list. Nodes. In the Nodes menu, all nodes connected to the platform are displayed. For each node, real-time information is shown about resource utilization, the number of virtual machines, their statuses, the cluster where the node is located, and the storage connected to it. Nodes have a maintenance mode. When this mode is enabled, objects can be evacuated to other nodes in the cluster. Once maintenance is complete and the mode is disabled, virtual machines will be returned to their original locations. The node card displays general information as well as data on node utilization and the last event. The full history of operations with the node is available on the History tab. In network settings, custom network configuration can be performed on the node. If there are multiple interfaces and aggregation needs to be configured, it is possible to create a bond and specify the operating mode. All standard modes for Linux systems are supported. A Linux bridge-based virtual switch can be created from the node card. If necessary, the user can specify VLAN tag, interface, IP address, and gateway. Additionally, the settings display a graphical diagram of network devices on the node, including physical interfaces, VLANs, and virtual switches to which virtual machines are connected. In the Disk Space menu, information is available about storage systems connected to the node. Statistics on node resource utilization over specified period are displayed graphically, including data on CPU, RAM, storage, I/O operations, and incoming-outgoing traffic speeds. In the VM distribution settings, node-specific overselling ratios and distribution filters can be configured. A node is added to the cluster by clicking the Connect Node button. The node must have an operating system installed without third-party repositories. Required software includes console utilities and SSH access. VMmanager will install and configure all necessary packages automatically. The user must specify the node name, the cluster to which the node should be added. VMmanager also automatically configures the network on the node. If custom settings are required, The Do Not Configure the Network Automatically checkbox must be selected. Next, the IP address, port, username and password for SSH access to the node are entered. The node connection process will begin, and once completed, the node will appear in the node list. Group operations are supported for nodes. After creating a cluster and adding nodes, the functionality for creating and managing virtual machines becomes available. The Virtual Machine menu contains a list of all virtual machines on the platform. For each virtual machine, information is displayed about resource utilization as well as the cluster, node, and storage where the virtual machine is located. The Virtual Machine console opens in a new browser tab. Operations for the virtual machine are available in the menu. The stop and restart operations can be performed forcibly. The Attach ISO image operation allows specifying the location of the image, either in the user's local repository or via URL. A custom image can be created from a virtual machine and used to deploy new virtual machines. If necessary, the image can be depersonalized, removing user data, settings, passwords, and other information. Virtual machines have a protection mode, which prevents accidental deletion or damage by administrators. It is also possible to block all actions on a virtual machine. Group operations are supported for virtual machines, including live migration, within a cluster, between clusters, or between storage systems. Migration works without shutting down the virtual machine even when using local storage. Selecting Virtual Machine Card. Information tab displays the main characteristics of the virtual machine. Virtual Disks menu manages the virtual machine's disks, adding new or editing existing ones. Backups menu shows a list of disk backups. The built-in backup functionality performs full backups. Snapshots menu manages virtual machine snapshots displayed in a tree structure. Snapshot storage method depends on the type of storage where virtual machine disk is located. In a file storage, snapshots are stored in the same file as the original VM. In LVM, a separate logical volume is created for each snapshot. Snapshots are deleted when the virtual machine is removed. Snapshot settings can be configured by the administrator. IP addresses menu manages the virtual machine's IP addresses. Automation can statically assign an IP in the guest OS. Network settings manages network adapters of a virtual machine. When adding an adapter, the user specifies the switch to connect to, the network adapter type, IP assignment method. Built-in mechanism will issue IP address from a specified pool. It is possible to provide its specific IP address or get it from DHCP server. Network interfaces can be added without rebooting the virtual machine. Virtual machine resource consumption statistics over a specified period are displayed in graphs. The information is available for vCPU, RAM, storage, I/O operations, incoming traffic speed, outgoing traffic speed. The History tab logs all operations performed on the virtual machine. Multiple operations are executed sequentially and displayed in the task queue. VNC SPICE Settings tab provides connection details and settings for connection of third-party clients to virtual machine console. Advanced Settings specifies resource allocations and limits for the VM. Creating a virtual machine. Virtual machine can be created from a configuration or a VM image, with optional support for link clones to save storage space. Creating a virtual machine from a configuration. First, select a cluster where the virtual machine will be created. When selecting a cluster, resource availability for this cluster is displayed. Then select an OS and its version. If the required version is not available, you can select it from the full list of OS templates or use an ISO image for manual installation of OS. Alternatively, create a VM without an OS. Then select a configuration template or specify a custom one. The next step suggests selecting a script for platforms to customize the OS or install additional software. Multiple scripts can be queued. Creating scripts will be examined later. You can specify node and storage where the virtual machine should be created. You can maintain default setting, in which case virtual machine will be created based on the distribution rules. Then you will need to configure network interfaces and network adapters. Set IP address. Up to 5 VMs can be created simultaneously via the web interface. For larger deployments, use API or the Terraform provider. Specify VM name, owner, and password. Then click Create Virtual Machine. Once created, the VM appears in the list. Scripts. VMmanager supports scripts for virtual machines and virtualization nodes. This allows automation of all processes. Scripts can be created directly in the VMmanager interface. When creating a script for virtual machines, you must specify the script name and who will have access to the script. There is an option to hide the script contents. Filters allow specifying which virtual machines the script will be relevant for. Scripts support parameters. These are requested before script execution. You can use variables declared in the platform. For Linux machines, these are shell scripts. For Windows machines, PowerShell scripts. Scripts are executed using the guest agent. The script results, including files, can be sent by email. For this, you need to set up notifications. For automating repetitive tasks on virtualization nodes, you can use node scripts, either shell or Ansible scripts. Variables for scripts are placed on a separate tab. Here you can declare your own variables, set values, and define the variable's scope. Backups. VMmanager allows creating backups of virtual machines and managing them. A backup can be created on demand, or a backup schedule can be set up. When creating a schedule, it is necessary to specify the time, location, and list of virtual machines for backup. Created backups can be limited by quantity or by the size they occupy in storage. To connect storage, the following must be specified: IP address, username, password, or use of SSH key for connection. How much space can be occupied in the storage, storage availability in clusters. We have finished reviewing the main objects of virtual infrastructure managed by VMmanager. Now let us look at the Platform Settings menu located on the right. The Notification Center allows configuring email notifications for events from virtual machines, virtualization nodes, and tasks that run on the platform. For monitoring, Zabbix can also be used. Ready-made templates are available on the service website. Task List. For each task, there is a card showing unique request ID for faster log analysis. It shows who launched the task, when it was launched, from which computer, execution results, launch parameters. There is built-in Swagger for testing your API requests and embedding VMmanager into company business processes. All functions available through the web interface are also available via API. VMmanager has a built-in Grafana service with pre-configured graphs and dashboards for comparative analysis of resource consumption, exporting data to external systems. Platform Settings shows license information and platform version. VMmanager is licensed by the number of physical cores, the number of nodes connected to the platform. When updates are released, Update Platform Now button appears. All VMs continue working during the update. HA cluster works regardless of platform availability. It is not recommended to launch new tasks during update. For closed-loop systems, updates come as ISO image and are installed with a single update.sh command. Email settings configure mail server integration for notifications. Client service section configures what's shown to users under question mark. By default, question mark button links to documentation. Security Policies section configures the interval between password attempts, the number of incorrect attempts, lockout period. This facilitates protection against brute force attacks. Sync Settings Active Directory include information for connection to the directory. Then, directory group to platform role shall be mapped. Then automatic sync interval shall be specified. You can use Modules tab to set up and configure integration with IP Manager and DNS Manager to create unified IP address space. Backup of VMmanager platform itself is recommended to be configured right after installation. To do this, you need Add Schedule, specify backup timing, and location. Backup restoration takes 10 to 20 minutes. The platform can work through proxy. You can use Statistics settings to configure data retention period and storage policy names. For load balancing need in a cluster, policies should be enabled. Migration section is for migrating from previous versions of the platform. Migration from other virtualization platforms is described in the documentation and consists in converting virtual machines disk to Q-code 2. We have covered the main VMmanager features. Find more information in the documentation.